All right. Anyhow, this is a 4.5 inverse matrices, and then we're going to solve systems after we understand how to do inverse matrices. All right, so a little refresher, identity element matrices. We've done this already. This part is review. Only square matrices have inverses or have an identity element matrix, and so if you remember on the diagonal you have your ones and all the other spaces are filled with zeros. Right, that was the identity element matrix for a 2 by 2. And therefore, then, if you do a 3 by 3, again, you're doing ones on the diagonals. And you're filling every other spot in. Every other element is a 0. Okay, so no big deal there. We've already dealt with that topic, but now we need to use it. So, number 2, when a matrix is multiplied times its multiplicative inverse. And this is what we're after. The multiplicative inverse. That's what we need. That's what we want. Because from pre-algebra, I made a statement like this to you guys. Things multiplied times a variable are moved by multiplying by the reciprocal. Well, that's the same as the inverse. The reciprocal and the inverse are the same things when you're talking about multiplication. So we're going to need to figure out the reciprocal, the inverse, so we can solve equations. And that's where we're heading. That's where we're going. Okay, so let me finish the line. So when you multiply a matrix times its multiplicative inverse, then what you end up is with its identity element matrix. This isn't really the purpose of why we're learning this. This is just a sideline that to help you to understand that it is indeed the inverse. Remember the inverse property? A times 1 over A equals 1. 1, the identity element of multiplication. So a matrix times its inverse should equal then the identity element matrix, because we're dealing with matrices, not with variables. Okay, so that's the situation, and then we're going to learn how to use them here in a minute. Okay, so we've got the matrix 1, 3, 2, 2, and then is this indeed its inverse? All right, we got to go back to multiplying matrices. So, do you remember the pattern? Across and down. That's what we've got to do here. Okay, so let's see if you can follow. Stay with me. By the way, we have a 2 by 2 times a 2 by 2, which is great. The columns of the first matches the rows of the second, right? And let me just take a minute and write it. Remember, to be able to multiply matrices, those have to match, and they do. And our resulting matrix will be a 2 by 2, right? So we are able to multiply them. Now we got to get back to multiplying matrices, not scalar multiplication, right? Multiplying matrices. All right, so the first element is going to be 1 times negative a half. And hopefully you agree that's negative a half. And remember, we're doing across and down. So as we go across the top row, now we're at the 3, right? And what do we have to multiply the 3 by? We got to go down to the half. So it's going to be a 3 times a half. Not a problem. That's a 3 halves, right? And I went across the top row and down the first column. Now let's go across the top row and down the second column to get the second element on top. And let me actually get a little closer here. So now you're at 1. 1 times 3/4, right? It's 3/4. And across is the 3, and down is the negative 1/4. So a positive 3 times a negative 1/4 is a negative 3/4. And we did the top row. Okay, let's work across the bottom row and down. 2 times negative a half is a negative 2 over 2, right? That's a negative 1. Working across the bottom row, I get to this 2, right? And then working down the first column, I get to that half. 2 times a half is a 2 over 2 or a 1, right? And now I got to work again across the bottom row and down that second column, right? So 2 times a 3/4 is a 6/4, right? A 2 over 1 times a 3 over 4. Again, some of you guys are fractionally challenged, and I know not why. But look, a 2 times a 3/4. 2 times 3 is 6. 4 times 1 is 4. It's a 6/4. Okay, and it's all you're doing. Top times top, bottom times bottom. That's all there is. Second one now, the second 2 on the bottom row of the left matrix times the bottom of this second column, which is a negative 1. You end up with a negative 2/4, and I'm just going to leave it that way. You can do plus a negative 2/4 or minus a 2/4. It's the exact same thing. Okay, so let's interpret all this. Left, top left. Negative 1 plus 3 is a 2. Put it over the common denominator of 2. 2 over 2 is 1. To the right there, 3/4 minus 3/4, 0. Bottom left, negative 1 plus 1, 0. Bottom right, 6 positives and 2 negatives is 4 positives. Put it over the common denominator. 4 over 4 is 1, and voila, look at that. We get the identity element matrix. Because when you multiply inverses, you get the identity element matrix. You have to. Any questions so far? Julia? Oh, I could have. I could have. I just didn't need to. I could have. Didn't matter. I know other ones I reduced them. Either way, it's going to come out the same way. Okay. Remember, and this might answer your question, Julia. I'm not done here yet. I'm not done. I'm doing all of this to get that. So I know I'm not done, and I don't know what I didn't know what the denominator of the other one was going to be. If let's say this one was a 1/4, okay, instead of a 2/4. If I would have in the beginning reduced this to a 3/2, and this would have been a 1/4, I would have now had to unreduce it to be able to add them. So I would have wasted my time reducing it. Now I got to spend more time unreducing it so I can add them up. So that's why I didn't bother reducing it. Didn't know yet what the other one's going to be. I'll wait. Because again, our final answer will be reduced, but I'm not anywhere near a final answer yet, and so no need to worry about reducing it all the way yet. Hopefully that answers your question. All right. Okay, so this looks familiar. Go ahead and do the multiplication on this second one. You need to practice. I'm going to pause the video. All right, you can keep working if you want. Top left, negative 1/2 and a positive 3/2 leaves you a positive 2 over 2, and that is a 1. Top right, negative 3/2 and a positive 3/2 is 0. Bottom left, 1/2 minus 1/2 is 0. Bottom right, 3/2 minus 1/2 is 2/2. 2 over 2 is 1. What can you conclude? Can you come to a conclusion? Can you make a theorem, or can you postulate something that you just maybe discovered as we did those two? Anybody? Abigail? Okay. Really, the identity elements are on the right, and the other ones are inverses. So, so B is the inverse of A, and A is the inverse of B. So that's true. What else can you conclude? Thinking of properties. What can you conclude, Hunter? What kind of, doing what to matrices? Okay, multiplying matrices is commutative. At least they're inverses. Yes. So, and that has to be the case because they're already inverses. So whether you take A times 1 over A or 1 over A times A, because they're inverses, we're commutative and we're good to go. All right, so multiplying inverses is, by the inverses, commutative. Either way, you're going to end up with that identity element. Okay, all of that is just really to begin to get us to this point. Formula. What about finding the inverse? Because we're going to need the inverses. Let me get rid of my shades so I can go higher. All right, we're going to need to find an inverse. We need the inverses. Again, let me just take a second and refresh your memory of what in the world we're doing. Okay, so again, if I had, don't need to write this, 3x over 5 equals 7/11. And we were solving this equation, we would multiply both sides by the reciprocal, which again is the inverse, and we'd be able to solve the equation. Well, what if you had something like this? Okay, we did the other day solving a matrix equation when you had something added to the variable, right? That wasn't so bad. You add its opposite to both sides. And we had maybe a scalar multiplier of the variable. What if you have a matrix multiplier? We got to multiply both sides by the reciprocal of this, right? It's inverse. So that's why we need to learn this so that we can figure out what to multiply both sides by. So we can solve the matrix equation. That's where we're heading. That's what this is all about. So to do that, we got a nice formula. It's a little bit complex, so be careful. It's a little bit complex. Okay, first off, this notation and this notation are the same. It simply means the inverse, right? And I take that back here. I misspoke a little bit here. Let me go back in 1 second. First one is the inverse. That's the inverse notation. Hey, if you had a to the negative 1, it would be the same as 1 over a, right? That's inverses, right? A to the negative x equals 1 over a to the x, or x to the negative a equals 1 over x to the a. Okay. That's the inverse, and that's the notations. This is what we're after, the inverse. How do you find it? This is the formula of how to find it. All right, so we're after the inverse. A to the negative 1. That's the inverse. How do we do it? Okay, this is the determinant of matrix A, right? That bottom part, the 1 over, is the determinant. So this part right here is the determinant, and we're going to multiply 1 over the determinant times what we have next. Again, a little bit complicated. What does the rest of it end up? Okay, I'm taking my red because I'm trying to look here, right? So here's your original. And how do you turn this original into its inverse matrix? You swap the D and the A. That might make a little bit of sense. Swapping the D and the A. So again, we got to come up with its inverse. The other thing you have to do, I'm going to take my red And I'm going to put a negative in front of this one and a negative in front of that one on the diagonals, both of them. And then I'm going to take my black and I'm going to keep those letters the same, B and C. Okay, that's complicated, I know. All right, there's complexity there. But it is a pattern that we can learn. So how are we going to find the inverse of this matrix? We're going to scalar multiply by 1 over the determinant of the matrix. And then times, we're going to take that original matrix, top right, bottom left, we're going to swap. Right? Top left, bottom right, we're going to swap. Top right, bottom left, we're going to put a negative in front. All right, complicated, but doable. Who can't come up with it? Forget it, all right? But somebody did, and we'll use it. So once you see it, look, if you have notes, you should be able to follow it, right? Just follow what we did. You got to look at the patterns. All right, let's try it. So here's K. We're after the inverse of K, which is K to the negative 1. That's what we're after. To do it, we got to multiply by 1 over the determinant of K. That we got to figure out, right? So determinant of K, right? 1 times 4 is 4. Come back the other way is a negative 1. Negative 1 times 2 is 2. Negative 2 times 3 is a negative 6. Value of the determinant of K, here, let me do this notation, right? Value of the determinant of K is negative 2. Therefore, this negative 2 goes down here. So let me pause. Follow what we did, right? We're doing 1 over the determinant of that matrix. That's the multiplier of what we get when we swap everything else around, if we're going to find the inverse. Again, ask questions as we go. Don't stay in the dark too long. Okay, I got to swap the 1 and the 4, right? And I got to put a negative in front of the other 2 in the corners. Top right stays as a 2, but now it's got a negative in front. Bottom left stays as a 3, but now it's got a negative in front. Okay, that wasn't horrible, was it? I mean, that wasn't extremely bad. Okay, here's the problem, though. Fractions again. Oh, I'm so scared. I'm quaking in my boots. Okay. 1 over negative 2 times 4. Can you handle that in your head? We get a negative 2. I'm doing scalar multiplication, right? Remember, we're multiplying times every element. So I did 1 over negative 2 times the 4 in the top left, right? Now I'm going to do 1 over negative 2 times the top right, which is negative 2. And that's pretty simple. That's a 1. Right? Try to pick easy ones to begin with. And now we got to do the 1 over negative 2 times the negative 3. It's a fraction, but it's not so bad. That's a 3/2. And then a 1 over negative 2 times a 1 is a negative 1/2. We just found the inverse matrix. So if we had an equation with this matrix as the multiplier, then we can multiply both sides by this inverse matrix to solve the equation. Right, Destiny? Her eyes were closing. You can't see because she's in front of you all. All right. All right, so that's the idea. All right. You want to try it on T? All right. Try to reproduce. You need to. You really do. Your brain's got to direct you. You got it all right in front of you. I'm going to pause the video. That was Swappo Wapo. Negative, negative. Negative, a negative. Whoops. 2. Negative of 4. So this is going to end up being a plus, right? One half times negative 3, negative 3 halves. 1 half times positive 2 is a 1. 1 half times a negative 4 is a negative 4 over 2, which is a negative 2. And 1 half times 2 is 1. There we go. Negative 3 halves 1, negative 2, 1. Anybody concur? Abigail, question? Concur. Concur. You were quick on your concurrence. So, all right. Not so bad for 2 by 2s. I'm not even going to deal with 3 by 3s. Hey, by the way, let me throw in a commercial right now. All of this is really itty bitty baby math, I hate to say. Because be a senior and get in Mr. B's calculus class, or go to college and take calculus, and then you'll learn other ways to do all this stuff. But it is what it is. Learn it while you can. Understand the patterns. It'll help you later on. I'm going to keep going. This is going to give you more time tomorrow or Monday. So let's do number 4. So what was the point of all that? To strain our brain, of course, so that we can solve equations, as I've mentioned to you. So how do you do that? Multiplying by the inverse, which again is the same as the reciprocal. The inverse is the reciprocal. So on the left equation, if I didn't do the shortcut, I'd multiply both sides by 1/5, right? The inverse, 1 over 5 is the inverse of 5 in multiplication aspect, the reciprocal. And again, this is just an illustration. That's all that is. But I multiply both sides. So what would you do with the matrix equation? Multiply the left by the inverse and multiply the right by the inverse. What you really end up with is the variable matrix, the resulting matrix, and the variable in this case is a matrix, will be the inverse times the matrix on the other side. That's what it's all about. So now we can solve a matrix equation. When the multiplier isn't a scalar, the multiplier is a matrix. Like this. So example A, X is a matrix, and its multiplier is definitely a matrix, right? So if we're going to solve this thing, we need to first find its inverse. And so then shortcut, what's going to end up happening is the inverse will be right here, and we'll be able to solve the equation. So that's what we're after. And I'll save that one for Monday. All right, that's it for today.